A runner travels 100 meters east and then 100 meters west. Did they travel 200 meters or 0 meters? The answer is actually both. Understanding why the answer is both will help you solve nearly every kinematics problem in AP Physics, and I'm going to explain why. In order to understand why the answer is both, we have to understand two concepts. Those are distance and displacement. Distance can be described as the total distance traveled, whereas displacement is the distance from the initial starting point. So let's imagine it on a number line. If we have, here is 0 meters, and over here is 100 meters, our runner starts at 0 meters. They travel 100 meters this way, and then they travel another 100 meters this way, because first they go east and then they go west. The distance here is 200 meters, because they travel 100 meters east, and then they travel an additional 100 meters to the west. So the total distance that they have traveled is 200 meters. Their displacement, however, is 0 meters because they end up exactly where they started. Let's look at another example. Let's say instead, again with our number line, we have a runner who starts at 0 meters and then they travel to, we'll say 10 meters and then back to 4 meters. So first they go east to 10 meters, and then they travel west to 4 meters. What is their distance and what is their displacement in this case? Well, the distance traveled, first they go 10 meters, that's this arrow here, and then they travel back 6 meters because they travel to the 4 meter point. So this is 6 meters. So their distance is 10 plus 6, which is 16 meters. Their displacement, however, or their distance from their starting point, is only 4 meters. Another important concept to understand in AP Physics 1 is the difference between velocity and speed. Just like displacement and distance, many people think that these are the same thing, when they're actually not. The easiest way to differentiate them is that velocity has a direction, whereas speed does not. The equations for each, let's look at speed first. Speed is the total distance divided by time. And velocity is the displacement divided by time. So let's look at an example. If we take our initial problem with the runner, where they travel 100 meters east and then travel 100 meters west, we already found that our distance is 200 meters. So I'm going to plug that into this equation here. And our displacement we found was 0 meters. Our time, let's say it takes them 40 seconds to travel the whole distance. Our speed is 200 meters divided by 40 seconds, which equals an average speed of 5 meters per second. This is the average speed because we're looking at the speed over the whole time that he was running. The velocity is going to be 0 meters divided by 40 seconds. And of course, 0 divided by anything is 0, so our velocity is 0 meters per second. It's important to understand the difference between speed and velocity. And it is very important to understand that velocity is directional, whereas speed is not. The final concept I wanted to go over is acceleration. Acceleration is defined as the rate of change of velocity. So it's best described in an example. Let's say we have a new runner who starts on the left over here from rest. So his initial velocity is 0 meters per second. He runs over here. It doesn't matter too much how far he runs, but when he gets over here, he's traveling at 20 meters per second. That change in velocity from 0 to 20 is a change of positive 20 meters per second. This means that our acceleration is the final velocity minus the initial velocity divided by the time it takes him to run this. For simplicity's sake, let's say 20 is divisible by 4. Let's say it takes him 4 seconds to run whatever this distance is. So we do final velocity minus the initial velocity divided by time it takes to run or to travel. So this is 20 meters per second minus 0 meters per second because he starts at rest divided by 4 seconds. So this is 20 meters per second divided by 4 seconds. And then for our units, the seconds combine on the bottom. 20 divided by 4 is 5. So we end up with 5 meters per second squared as our acceleration. Acceleration, since it is based on velocity, which you remember is directional, is also directional. Let's say we have an example where our runner is now slowing down. So here, he's starting at our 20 meters per second, and then he's slowing down to a light jog at 8 meters per second. I'm not a runner, so I don't know if 8 meters per second is a light jog or not, but that's not that important. And let's say that the time he takes to slow down is 4 seconds. Again, we do final velocity first minus initial velocity. So we do final velocity minus initial velocity divided by time. So this is 8 meters per second minus 20 meters per second divided by our 4 seconds. 8 minus 20 is, let's see, it's negative 12 divided by 4 seconds. Again, the seconds combine on the bottom. So we have negative 3 meters per second squared. It is important to realize that this acceleration is negative because the runner is slowing down. Acceleration is all about direction, just like velocity is. So as the runner slows down, the acceleration is negative, and as the runner speeds up, the acceleration is positive. Negative acceleration doesn't necessarily mean moving backwards. It only means that you are decelerating. So if a car is braking, it is decelerating, which means the acceleration points in the negative direction. Let's look at a more three-dimensional example now, where instead of traveling along a number line, a runner, let's say that they first travel 100 meters north, and then they travel 100 meters to the east. Their distance here that they've traveled is again 100 meters plus 100 meters. So the distance is 200 meters. Their displacement now is the distance from where they started. So it is the length of the hypotenuse there, calculated using Pythagoras' theorem, which is a squared plus b squared equals c squared. The Pythagorean theorem is going to be one of the most useful theorems to use in AP Physics 1. So it is c squared equals a squared plus b squared, where a and b are the two legs of a triangle, and c is the hypotenuse. So we can solve for c by taking the square root of both sides. So c equals the square root of a squared plus b squared. So in our case here, c equals the square root of 100 squared plus 100 squared. You can plug this into the calculator and you get 100 times 100 plus 100 times 100. And then if you take the square root of that, it is roughly 141.42 meters. So that is the length of C, and that is their displacement. So again, the distance here in this problem is 200 meters, and the displacement is 141.42 meters. Let's do a speed velocity practice problem now. Let's say that we have a cart that travels 120 meters in one direction, say to the east, in 10 seconds. So it is 120 meters, and it takes 10 seconds to travel. What is the average speed and the average velocity? The average speed is the distance divided by the time. So our distance is 120 meters, and our time is 10 seconds. So this is 120 divided by 10 is going to give us 12 meters per second speed, average speed. Now what is the average velocity? Well, in this case, it's the same. Our displacement, since the cart traveled in one direction and it didn't turn around at all, is also 120 meters. So we can say that our speed, average speed and average velocity are both 12 meters per second. So speed and velocity can have the same numerical value if you're only traveling in one direction and you don't turn around at all. Let's do one final example problem now with acceleration. Let's say that our cart accelerates from an initial acceleration of 5 meters per second, an initial speed. It accelerates some distance to 17 meters per second over here. So here is our initial velocity, and here is our final velocity. Let's say it takes 4 seconds to travel that, or to make that change in velocity. So we have our final velocity minus our initial velocity, 17 minus 5, divided by 4. 17 minus 5 is 12, divided by 4. We have again 3 meters per second squared as our acceleration. I hope this video was helpful. If it was, please like and subscribe. In the next lesson, we'll move from these definitions into actually graphing them, where you'll learn how to find velocity and acceleration directly from position versus time graphs.